long, skinny one.
Smaller one.
And then there's the little chunky one. And oh, hey, sorry, Warren. Hi, guys. Welcome. Laneway Lab, as usual, lovely to have you on board. Or if you're watching on demand from our resources locker later on, well, we won't see you now, but enjoy watching us later on. You might have noticed that things look a little different today. Ken hasn't changed his hair. Ken's not with us today at all because today is a special episode. It's a sisters episode.
Yes.
We've got the lovely Tasman joining us today. Now, I will briefly talk about what the Sister Project actually is because this is something really special to me and to Taz, right? The Sister Project is an Australian government-funded project that Street Science has undertaken. And what we do as part of the Sister Project is we're trying to show people, kids, junior scientists all around Australia, that scientists can be anybody and anybody can be a scientist.
Absolutely.
Right? We're not all these old guys in white lab coats with crazy hair like Ken's.
No.
Anyone can be a scientist, and we are both proud women in science ourselves. So I thought, what better way to showcase the diversity, the huge range of scientists in our world than by interviewing our very own, not just Tasman, but Ranger Tas.
Ranger Tas, exactly right.
You heard right. She's a ranger. She has been before she came to work with Street Science. And it'll be really cool to hear Taz's story today. If you do have any questions for Taz as well, do jump into the comments section or leave a question on our Q&A tab. You can even jump on social media or send us an email if you've got any questions for people like Ranger Taz or any of our presenters about what we've done in our science careers. But I think we should dive right into it.
Absolutely.
Yeah? So you're my interview guest today. I'm sorry I didn't give you a glass of water or a fancy chair to sit in.
Oh, that's okay. I'm fine. Thank you very much.
But I would love just to start with, what's your story?
Well, when I was a little kid, I absolutely loved animals, and I loved them so much that I wanted to learn how to protect them and their environment. So after school, I went to university and I studied something called animal ecology.
Ooh, fancy.
Yeah, so that's like the relationship between animals, their environment, and humans, and how we can protect them. And I specialised in something called climbing lizard biomechanics. So I think we have some photos that we can show you of me with some lizards.
Biomechanics is movement of stuff, right?
Absolutely. So I was studying how lizards would climb up and down vertical surfaces.
Ah, there we are. Definitely a vertical. That's a straight vertical surface.
Exactly. Jeepers. So I actually built a vertical racetrack. You can see it in the photo there. And I would get lizards to climb up and down that track, and I would film them doing that so that we could study the way that their limbs moved and study the differences between climbing up and climbing down.
Is that one a lace monitor?
Absolutely it is.
Goanna, right?
Yes, that's a type
Very
of goanna,
cool.
exactly. I actually had to go out west to collect data on those ones. That was a really, really fun trip.
Were you catching these lizards yourself?
Absolutely I was.
Oh,
it was
jeepers.
super duper fun. A little bit scary, but when you know how to do it properly, then it's totally fine.
So you took these videos of these climbing lizards, very
Yes.
niche, I can tell you.
Exactly.
And then?
Oh, well, this study actually took me to a place called the Galapagos Islands. So if we go to the next set of photos, you'll actually see that I got to collect data on this type of lizard called a marine iguana. And we had to go to the Galapagos Islands because these marine iguanas are found nowhere else in the world.
They're pretty important from like a diversity and evolution in biology as well, right?
Absolutely, and they're actually the only type of lizard in the world that lives on both land and in water. They're really, really cool. Then the reason I was collecting all of this data is because if we can figure out how lizards climb really well, we can actually apply that to robots. So in the next set of photos, you'll be able to see, there we go, I'm holding some climbing robots. So we applied how robots climb to these robots. Sorry, the lizards climb to these robots.
I've got to interrupt here. So
yes,
you used biology to create robots.
Exactly.
That's epic. And this is like a really cool pairing of STEM, right?
Yeah, it's actually called bio-inspiration, and it's used in engineering all the time. It's really, really cool.
I think I know another example from lizards though.
Yes.
Velcro?
Velcro, yeah, absolutely. So the way that lizards' claws cling into surfaces is really similar to the way the Velcro works.
Yes, I knew something
Yeah,
about
very
it,
clever,
right?
yes.
But I see you've got a really cool group of people there. You made robots that could climb the way lizards climb.
Yeah, so cool.
Very cool.
After I finished university, I realised I wanted to keep learning about animals and the environment, so I decided to go and work at a place called Gari. Now, we used to know Gari as Fraser Island.
Have heard of that.
Yeah.
Yes.
But now we call it its traditional name Gari, and that actually translates to paradise because it is a beautiful paradise island.
What a beautiful name for it. Thank you, First
really
Nations
nice.
people.
Yeah. So if we look at the next photos, you'll be able to see me working as a resort ranger on Gari. I got to do heaps of really cool things there. There are so many amazing habitats on Gari to explore. And I got to teach guests who came to the island about all of these different environments. And yeah, I really loved it. If you look at the next slide, you'll see some more photos of me doing some cool things. I got to go up in this plane.
That's a small plane.
Yeah, it was quite scary. It was really shaky, but it's super fun. And I got to like handle snakes, which you can see there. And if we go to the next slides, you'll see some of the tours I used to run. I would
Segways.
Yes, I would do the Segway tours. I did canoe paddles. It was, yeah, really just an amazing job.
That doesn't look very sciencey, I'm going to be honest.
I
What
know
you're doing there in a canoe, on a Segway, I know it's still science, but it doesn't look like a regular park ranger work I would expect. You know, watching people go out and collect data and things like that. So are you really a park ranger?
That brings up a great point, Jess. So I was a resort ranger. A park ranger is a slightly different job.
My mistake. No offense intended.
And look, not a lot of people know the difference. So park rangers, they actually work for the Queensland Parks and Wildlife Service, and their job is to basically maintain the whole island, keep it really nice and protected.
Because the whole island is a national park,
Exactly,
right?
yeah.
Okay.
So it's the world's largest sand island, and it is a heritage listed island, so it's really heavily protected. So the park rangers there, they do things like fire management. So they, Guyri is actually really susceptible to bushfires, so they would do control burns and reduce the risk of bushfire there. They have to enforce like laws to do with fishing. They have to make sure that people are responsibly fishing in that area. Yeah, they have to do heaps of really, really important work. They have to gather lots of evidence. They have to do flora and fauna surveys so they can properly protect the environment. They have to teach guests on the island about dingo safety, because you may have heard the dingoes on Guyri.
They can be dangerous.
Absolutely. Not a lot of people realise they're not like dogs, they are wild animals. And so a lot of education has to go into that. And that's where the park rangers come in.
That's really, really cool.
Yeah.
Jump back up to full screen, because I feel like Taz has got some really cool stuff to tell us about this. So not only did you do some really amazing things as a resort ranger, which you got your job because of your understanding of ecology.
Exactly.
Right? But you were sharing your love for ecology, but doing it in a different way.
Exactly.
You weren't actually out there measuring animals or collecting bird poo or all of the beautiful nitty-gritty that biologists get to do. But you got to do Segway tours instead, and sharing that passion with other people.
Exactly.
That is really great job.
Yeah, it's really, really fun. Would you like to hear what a day in the life of a ranger actually looks like?
Yes, if there's no bird poo involved, I'm definitely here for
Luckily, no
it.
bird
A
poo
classic
involved.
day in your job as
Yes.
a resort ranger on Guyri in the national park.
Yes, so different to a park ranger. As a resort ranger, my day looked very different every day, actually. That was the great thing about being a ranger, is no days looked the same. But let's just think of a random day. Maybe I would get up really early in the morning and I would go down to the beach and I'd set up all these canoes on the beach for the ranger guided canoe paddle. I would take guests down the beach and we might go into the mouth of Dundonga Creek, where sometimes we'd see stingrays and we'd see turtles every now and then. After the canoe paddle, I would go and greet some of the guests arriving on the ferry. I would show them how to get up to the resort and welcome them to the island.
So lots of customer interaction or personal interaction.
Absolutely. We wanted to make sure that every guest on the island had a really personal experience, not just at the resort, but actually with the environment itself. So that's where we came in. After a quick bite to eat, I might take some guests out on a four-wheel drive tour to some of the sand dunes. And sometimes at the sand dunes, we would find something really cool. You've got a little cup rat in front of you there, Jess.
The things that I was playing with before.
Yeah. So this is actually called fulgurite.
Fulgurite.
Yeah,
Hold
now
it up here.
fulgurite, there we go, you should be able to see it.
I'll hold it flat on my hand so we can focus
There
a
you
bit better there.
go, wonderful. So fulgurite is actually fossilized lightning.
Pardon?
Yeah, fossilized lightning. It's pretty crazy. So sand actually melts at 1,700 degrees Celsius, but lightning can get up to 23,000 degrees Celsius.
That
way hotter.
Is a very, very high number.
Really
Lightning
high
does
number.
have a lot of energy involved in it
Exactly.
too, right? Like it has so much energy that it can fix nitrogen gas out of the air into soil.
So
it makes
energy.
sense that it can melt.
So that's exactly what happens. When lightning hits a sand dune, it can melt bits of sand. And you might know this, guys, but melted sand, that's actually how we make glass.
Ah, the silica.
Yes. So this is actually a type of glass, this fulgurite. So it's not like the glass that you might have seen before, but these are little glass shards. And they're not sharp or anything like that, but it's essentially just melted sand.
You probably can't see it, but if I look really closely on the inside, I can see it does actually have the appearance of glass. Like
Yes.
It looks like it's slightly more transparent, sort of got that that smooth sort of appearance on the very, very inside, which would have been where their energy was really centered.
Exactly. So this is a really cool thing that we would find sometimes in those sand dunes. Then, after a long day of searching for fulgurite, I would sometimes run something called the Junior Eco Ranger program. So that was really fun. We'd do that at night time. That's where we'd get some of the kids who were staying at the resort to come and join me, and they got to see what a resort ranger did. And so we would take them on a night walk. So we would take torches with us and we would go and look for different nocturnal wildlife. And we'd even take ultraviolet torches with us sometimes, because there's actually a type of scorpion on the island whose shell glows under ultraviolet light. So it made it like really easy to find these scorpions hiding in logs and things.
Just
like
these little glowing scuttling around.
Yeah,
on
you'd
the
see
floor.
their little pincers coming out of the logs. You could even like try and tickle them with a bit of grass, and they would bring their pincers out and try and catch it.
I never knew that you've tickled scorpions in
I
your
have
past life.
tickled scorpions
Tickled
before.
scorpions. What a
You
great
wouldn't
way to
think
use
so.
science.
Yeah, exactly. So yeah, it was always a really exhausting day, but super fun day. I got to meet so many people and talk to them about how amazing the island is and why we should protect it.
I think that's all really, really important. And do you think that those, moments of sharing your very obvious passion for ecology with these guests actually would have had follow-on effects? Like, do you think that they would have done anything differently in their lives afterwards?
Exactly. So it was our hope that by giving all of the guests a really personal experience with nature, and by giving them a better understanding of nature and how all the species in an ecosystem are really critically connected, that they would hopefully go home and they would take that into their everyday lives. They would make some choices which would positively impact the environment. They would make some, really responsible choices. Yeah.
And, well, I know most people really like animals. And
Exactly.
It's not really that hard to sort of make that connection once they've spent that time with you in those beautiful ecosystems of how their actions can really make a difference for those animals.
It would motivate them.
And I know I actually had a really cool experience doing something similar, not working with you, sadly, because you sound like an amazing resort ranger, but I spent a bit of time up at Mon Repos, which is on the mainland of Australia, not out on one of the islands, but it's this beautiful coastal area just out of Bundaberg where they have this huge, huge program about conserving turtle hatcheries.
I've heard of this program. It's fantastic.
I've got my little turtle friend here. I'm not going to call this one Shelley because that's unoriginal. Let's pop her like here, and her name is now officially Eileen. Hey.
Oh, I get it. That's funny.
She's leaning. Hey, no, not quite. But in Mon Repos, they had this beautiful educational area. I actually took my little children in, like a 2-year-old and a 5-year-old running around. And they learned so much about just turtles in general. And they were super excited when they came out of it, that they wanted to sort of try to do something to help the turtles. So even at that age, and all the ages you worked with, it's really cool how we can empower people to make a difference.
Exactly.
And I think we actually got some footage from Mon Repos. They've done some beautiful stuff for education. We've got a little video that they've shared online that we thought we would do our best to share what they do with their educational programs for the benefit of our beautiful turtles.
Awesome.
Let's watch it.
I've been coming to Mon Repos since I was very little. The first turtle I can remember seeing was a flatback. They just don't come up as often as loggerheads, and they're very different in their appearance to loggerheads. I'm Hurley Gatley and I'm a junior turtle ranger at Mon Repos. I became a junior turtle ranger because I really wanted to help with the conservation of an endangered species and make an impact on the future of the species. It's a really rare mix of conservation and tourism where people can come down and learn a lot but also see lots of different things that you can't see anywhere else. I think people need to come and be a part of this experience so they can see something you wouldn't see every day and take home a really important message about conservation in general.
Did you see the little turtles?
That was so cute.
Have you seen baby hatchling turtles?
I have not been lucky enough to, but it's on my bucket list.
I know, and that's what's really cool about Mon Repos, is they do it in a really sustainable way.
Absolutely.
And you'd have seen that junior ranger there was helping to educate groups of people, as you would have done as well.
Yes.
I didn't see any glowing scorpions though. No.
Well, then they'll have to just come to Gari to see those.
But what I did see was some actual rangers from a wildlife, I'm not sure which group it was there, but some actual park rangers that are there for the conservation of those turtles doing research, actually collecting evidence. Were you paying attention?
I was, I think.
Well, then we've got a little poll you can participate in.
Okay.
We'll get our viewers to participate as well. You'll see a poll popping up in your side tab wherever it is with a little question. Which evidence gathering methods did rangers use in this clip of Monrepos Conservation Program?
Okay.
Right, so have a look on there, Taz. Have a think about it. The options we're looking at, you viewers, jump in, put your answer in. There's 3 options. They measured turtle carapace length and counted the eggs.
Yep.
They measured turtle carapace length and the sand temperature. They measured turtle carapace length and the turtles completed an online survey. All great inquiry methods. Yeah, measuring, collecting quantitative data, collecting qualitative data, collecting survey data.
I mean, I would love to see turtles completing an online survey. They might use I don't know if they'd be able to use a keyboard, so I don't know about that one.
With their flippers. I can see it happening.
That might be tricky.
I don't know if that one was
I don't know if that one is going to work.
We might cancel that poll for you guys. Give
Right,
that
let's
one
see who
a
got it
click.
right.
We're going to close it now. And as we think about our poll answer, Tasman, what was your answer? You don't think it was the online survey,
I don't think it was that one.
right? Did you see any turtle carapaces?
I think I did.
Yes, that's the back of their shell, right?
Absolutely,
We call it the shell, it's called the carapace. They were being measured, so that part of it's correct for both of them. Then did they count eggs or did they measure the sand temperature?
Well, you know what? I think it could be either. I mean, I think one of these is definitely the right answer, but I think they could do both of those things.
They're both really important
both
things that
really
they measure
important.
for turtle conservation. But in that video, I saw them taking the eggs out and placing them in a beautiful little grid.
You're right, they had a little grid. I remember that now.
So they could measure them. And they have to do it really quickly too. Fun fact I learned about these, right, is they have to do it quite quickly because when the eggs are first laid, they're quite flexible, right? And they're
I
quite
have
strong.
heard that they're very soft.
But if you leave it too long, they get really, really soft like paper and you can tear them really easily.
Oh, well, you got to be careful.
So they do measure those eggs pretty much as soon as they've been laid, and Mama Turtle has made her way back out to the ocean. So the correct answer was, in fact, that first one. For those of you, all of you chose that.
Whoa, great
done.
work.
Right, they measured turtle carapace length and counted the eggs. And you mentioned before that measuring sand temperature would also be a really valid response, right?
Definitely.
Because there's some really cool stuff about sand temperature and turtle eggs.
Absolutely. So the sand temperature can actually impact the sex of the turtle when it's born. So if the sand temperature is too warm or too cold, it can actually affect whether it's a boy turtle or a girl turtle.
Which is one beautiful education piece they're doing at that
Absolutely.
particular conservation site to help advise people about how temperatures may be changing and how that could affect the turtles.
Exactly.
Now, you probably would have seen a bunch of field data being collected in your work on the island, right?
Absolutely.
What type of evidence would you have either witnessed or maybe even helped park rangers collect for their conservation and science efforts?
Well, in working with the park rangers, sometimes I would see them setting up something called a camera trap. So that's where they would go and put a camera which is like really sturdy and it can go into like a really wild natural area for days, weeks, or sometimes even months at a time. And these cameras, they can actually sense when something's moving past them. So if some animal moves past, they'll quickly take a photo. And then the rangers, they could actually use those photos to calculate what the populations of some of the species were on the island.
Like some of my friends' front doorbells.
Yeah, a bit like those ring cameras. That's absolutely right. They would use that sort of technology. Now, the rangers would then go through the photos, calculate the population size, and they would figure out that if the population size is higher than they thought it was going to be, that's really good. That population is doing really well. But if the population size is much lower than they thought it was going to be, that means that they would need to take that evidence and then use it to prove that they need to put more time and money into protecting that population. So that's why gathering evidence is super important and how it can actually affect change.
Like a direct relationship between how many of a certain type of animal there are in an ecosystem, that is really important data.
Definitely, super duper important.
But it's not just cameras. Like they actually get their hands dirty too, right?
Oh, absolutely. I've actually helped, not on the island, but when I was at university, I helped with a really cool kind of data collection where we would try and figure out koala populations.
Yes.
Have you heard of these koala detection dogs before?
I think they're very good at sniffing out poop, right?
That is exactly right. Very
Yep.
good at sniffing out koala poop.
Koala poop.
Because the way that we were counting koalas before was just by looking up into trees with our eyes. And if you've ever been on a bushwalk looking for koalas, You know, that's pretty hard, right?
Very tricky.
But these dogs, they are 700 times faster at finding koalas than us humans are, just because of their clever noses. So there are so many different ways that we can collect data and evidence on animals out in the wild, sometimes using the help of other animals, like dogs.
Very cool. And I wasn't really joking that much when I talked about collecting bird poop earlier in the stream, right?
So true.
I know koala poop is hugely important for anyone studying koalas, right? I also know wombat poop is really interesting too.
Absolutely.
Cube-shaped. Hey, fun fact for you about poop today.
I actually know why it's cube-shaped,
Oh!
if you want to know.
I totally want to know.
Okay, so wombats, they will do their poop on the top of a little mound, and then they knead it there so that other wombats can smell it, right? If it's on the top of a hill, the wind can carry the smell over to other wombats and let them know where they are.
Yep.
But if it was a sphere, like some other animals' poop, it just rolls off the hill. That's exactly right. But if it's a cube, it can stay there. How cool is
So
that?
the wombats, over the centuries of wombats that had the squarest poops survived
Exactly.
because their poop could be smelled further away.
So true.
Oh, the beauties of natural selection. Oh, so cool, so cool. So there's a bunch of different ways that scientists and field scientists can collect data. They use that to like understand things, and then people like resort rangers come
Yes.
along and share that information with anybody, everybody, so that we can each take tiny steps to improve our ecosystems around us.
That's exactly right.
It just wraps it up in a neat little package.
It really does. It gets everyone involved.
And then maybe some of those scientists leave those beautiful paradise tropical islands and come to work in the big city as street science presenters.
Yeah, that's exactly right.
I know you've joined us on the dark side or the light side, whatever you want to call it. We have a lot of fun as street science presenters, right? But what is your favourite thing about being a science educator now?
Well, my favourite thing about my job on the island was getting to talk to people about science and how it can protect the environment. So when I found out about street science, we go to different schools and places all over the country every single day talking to people about science, I thought, that's the job for me. So that is my favourite part, is actually getting to talk to people, like the students we visit in schools, but all the other people we visit, about why science is amazing and why everyone should be as passionate about science as I am.
And you get to blow stuff up.
Oh yeah, that's pretty fun too.
But you're actually a bit different to me in that your favourite demonstrations aren't always the big fire and explosions and things, right? You also like teaching people really important ecological stuff.
Absolutely.
And I did notice you brought something along today.
I did.
Are you going to do a demo for us?
I thought I might introduce you to my friend here, Freddie the Frog. Would you like to meet him?
I would love to meet Freddie the Frog. Does he shake hands?
I haven't trained him that well yet, unfortunately.
Sadly.
Yeah, that's okay.
Come pride of place in the middle for us,
Alright,
Freddie.
so let's move Freddie into the middle here so you can really get a good glimpse of him.
Did you make
He
him?
is. I did make him myself. Thank you.
Is he for anything in particular?
Yeah, so he's actually going to teach us about bioindication.
Bioindication. Bio, so a biological idea.
Yes.
Indication tells us something.
Gives us some information, exactly.
Cool.
So bioindicating plant and animal species, they are really sensitive to certain things happening in their environment, and then that can actually alert us to when something in an environment, it's a tongue twister, something in an environment has gone wrong. So frogs in particular are really good at bioindicating because they can breathe through their mouths like we can, but they can also breathe through their skin.
Yeah, that's why it's so moist, right?
Exactly, yeah. So they're really sensitive to changes in air quality and water quality. So there's some habitats where there's lots and lots of frogs living there, and ecologists, so those scientists who study animals, plants, the environment, things like that, they might be like monitoring the water quality in that habitat and not really know that anything's wrong. Whereas the frogs, because they're super duper sensitive to those tiny little changes, they can actually tell when something's wrong with the habitat well before the ecologists can.
Are you sure? Because I'm pretty good at tasting water. Like I could just pick up this water and have a little taste.
Yeah.
Except I'm not sure that's water.
I don't think, yeah, you don't know that that's water, Jess.
Let's leave that, right?
definitely
But
shouldn't
I think
drink
you're right,
science.
because even just like tasting water from different taps, sometimes I notice there's a little bit of a difference.
Exactly.
But there's so many more things in there that I definitely wouldn't pick up.
Yeah, that we don't know, but frogs, they might know.
They might know.
So, today I've actually brought a pollutant with me that I got ready in the lab.
Oh, dangerous.
Now, it might look like water, right? But just because something looks like water definitely doesn't
Shall
mean
I taste
that
it and
is.
find out?
Definitely not tasting this one, because I can tell you this is definitely a pollutant. Now, this flask right here, that is just regular old water. So I'm going to pour some of my pollutant into the water, and you should be able to see absolutely nothing changes.
Nothing
right?
whatsoever. Bring it here. We can go for a close-up from our
Yeah.
top cam, and yeah, there's nothing different about
It has not changed.
what I can see anyway.
Exactly. So we can see right now that nothing has really changed, but we don't know that nothing has changed. Whereas if I put some of the pollutant into Freddy the frog right here, let's see if he changes. Right now we can see that he's green. That means he's really, really nice and healthy. But watch what happens when I pour some of the pollutant in. In 3, 2, 1.
Oh no, Freddy.
Oh dear.
Jeez Louise, he is not green anymore.
He has gone red. That cannot be good.
He's gone from a green tree frog into a poison dart frog.
Exactly. He has turned bright red. So now we know that this pollutant is really, really bad. Because
Lucky I didn't taste it.
Exactly. The frog's not healthy anymore. So that's really sad.
And how would we know that in nature?
In nature,
Do they change colour?
No, they don't change colour. Instead, we would actually start to see their population numbers dropping.
So one of those cameras might catch less evidence of the
Exactly.
frogs, or you might hear less of them.
Yes, because some of the frogs we had on the island, they were super duper loud. They would be like really, really loud and chirpy. And sometimes we would hear less of those loud chirps, and that would let us know there's less of these frogs around. There might be something wrong with the water.
Oh, poor Freddy.
I know.
Is it all doom and gloom though? Is Freddy gone now?
Well, look, I do want to try something to help Freddy out here.
Yes, let's do it.
Now, I know that this pollutant was acidic because I prepared this pollutant myself. So I want to try and neutralize this reaction by putting something basic in there.
I know a little bit about this actually happening in
Yes.
nature, because nature is super robust in some ways, and then we can destroy it easily in others, right? And I know with a few of my geologist friends who are really down-to-earth people,
Good one.
know that there are certain types of rocks that are in themselves basic.
Yes.
Limestone rock is
Exactly.
basic. It has bicarbonates in it. So did you bring any rocks?
I didn't bring any rocks, but
Nope.
you said bicarbonates.
Yes.
That's got my ear ringing because I have brought something called sodium bicarbonate.
So we use that in our kitchen cooking.
yeah,
sometimes.
absolutely.
Limestone rocks have different bicarbonates in there, and they can dissociate from the rocks and mix into waterways and help buffer the systems.
Yes. So
Do you think it'll work?
fingers crossed this is what's going to happen for Freddy today as well. We're going to put some of this base in there, this sodium bicarbonate, and we're going to see if we can neutralize this reaction.
Hold tight, Freddy.
All right, Freddy, you're going to be okay. So I'm going to add 5 scoops of this sodium
It
bicarbonate.
needs a lot of neutralization. Hey, look.
Whoa.
Oh no, he's fizzing.
He's fizzing. He's fizzing. Is he going to go back to green? Oh, I'm starting to see a colour change already. All right, that's 5 scoops.
But even if he is changing colour back to green, that can't be good for Freddy.
I know. So that actually brings up a great point. Sometimes we can neutralize these reactions. We can reverse some of the effects of pollution, but it's never really going to go back to the healthy level that it was at before.
He's almost green.
He's almost green, but I think he's still looking pretty sickly. I don't know.
But hopefully he'd be well enough to, find another little froggy friend, maybe have
Exactly.
some little froggy babies
Yeah.
and reproduce, and those beautiful frogs could keep existing in that ecosystem.
He's got a future, that's for sure.
But maybe just best to avoid tipping your pollutants into the water in the first place.
Exactly, because sometimes reversing these pollution, like this pollution effect, it can be done, but it can cost a lot of money and it can take a lot of time. So it's best to just not pollute habitat in the first place.
Really cool, and a really cool visual way to show us a little bit about something that isn't so much fun about pollutants, but also recovering from pollution in ecosystems as well. Thanks, Taz. Really
No
cool.
worries.
Now, I happen to have seen this little Freddy before floating around in a particular show tub that you've been working on.
Absolutely. So I've actually been getting ready for National Science Week this year. It's
Yes.
not until August, but this year's National Science Week theme is species survival. So I have written a show for National Science Week, which you guys might have heard about. It's called Save Our Species, Our Survival Depends on Theirs. And this is a little sneak peek in that show because this is one of the demonstrations I'm going to use.
Spoiler alert.
Yeah, to talk about how other species surviving can actually help us humans survive as well.
Yes, we're all interlinked, right?
Exactly, critically connected.
And that's the beauty of ecology, right? Is everything is connected, whether it's the habitat where the animals are living, or the animals, us as humans, the sky, the chemistry and the environment around us.
All connected.
All connected, and it can be pretty interesting if you have the right people explaining it to you. Now, we are pretty much out of time. I don't think we've had any questions jump through in this session so far, but as always with our presenters, we love sharing our passion of science around. So if you do ever have any questions for us, jump on our social media, ask questions through there, email them to us, and we could do a little mailbag and answer your questions in a future episode. Thanks so much for joining us, Taz.
Thanks for having me. I've had so much fun.
Thank you, Freddie. Thank you, Eileen the turtle. She's gone to have a little sleep. Off to write some more shows.
I guess so. I better get back to work. Hey.
Get ready for school tomorrow and
Oh,
go out
yeah,
and blow
so
some
true.
minds.
Yeah, so I can explode some more things.
Thank you for joining us in the Laneway Lab today, guys. I'm Jess. This is Taz. We'll see you next time and have an awesome day.
Bye.